Hello, I'm John Brewington. Today we are making ice cream for my kitchen chemistry class. We have a third cup of sugar that's already measured in this cup. We got a cup of milk that will be measured. We're using 2 cups of heavy cream. It's a pint. 2 cups is already a pint, so it does not need to be measured. And then we are going for a tablespoon of vanilla for the flavoring that's already measured. We are not using eggs since it was optional. Okay, now I'm adding in all of my ingredients into a measuring cup so it can get poured into the stainless steel bowl. We have our milk, we have our creamer, sugar and everything. And that is our vanilla extract. And we are going to whisk it into our stainless steel bowl, which is non-reactive, and it won't interfere with the taste or texture of any of the ingredients that we added. Now that everything is mixed, I'm going to pour everything into a gallon-sized Ziploc bag. We will try to take as much air out as possible and seal the bag. Now I am going to use another large gallon bag in my attempt to make ice cream. I will be using this bag to add the ice into it. To enable the temperature of the ice to lower, I'm going to add 2 to 3 tablespoons of salt. I chose to use kosher salt rather than Red Cross iodized salt because I figured that the crystals in kosher salt are more coarse than the table salt, and the coarser crystals will serve better for lowering the temperature of the ice to freeze the ice cream more quickly. Now I am going to take the smaller Ziploc bag with the ice cream mixture and place it inside the larger Ziploc bag, which contains the ice and salt mixture. I wanted to add more ice to the bag just to be safe because I didn't want the ice cream to not be icy enough. Now I am going to seal the bag and release as much air as possible. Let's shake this bag for 10 minutes or until the ice cream mixture is frozen and I have reached my desired consistency. In the meantime, let's get behind the science of what my ice cream making is. The ice has to absorb energy in order for it to melt. This is an endothermic reaction because energy is absorbed for the phase change to take place. Sodium chloride, aka salt, is added to the ice to lower the freezing point of water. Salt can help lower the freezing melting point of water. Therefore, changing the phase of the ice from solid to a liquid. Adding salt to the ice that surrounds the ice cream base provides a temperature cold enough so that the ice cream inside can thicken and freeze before the ice outside the base entirely melts. When I use ice to cool the ingredients to make the ice cream, energy is absorbed from the ingredients and from the outside environment. When salt is added to the ice, it lowers the freezing points of the ice, so even more energy has to be absorbed from the environment in order for the ice to melt. This makes the ice colder than it was before, which is how the ice cream will really freeze. Salt is an ionic compound which breaks into sodium and chloride ions and are better at lowering the freezing point at which water will refreeze into ice. By adding sodium chloride, which is our salt, a solution is formed with the water. The forming of the solution interferes with the orderly arrangement of the particles in the ice crystals. Therefore, more kinetic energy or heat must be removed from the solvent, which is water, for freezing to occur. This results in a lower freezing point. 10 minutes have passed. Let's take a peek at how it's going. I'm now removing the smaller Ziploc bag from our larger ice bag to check on the consistency of our ice cream. It's looking pretty good. I will admit, I was a little sus about how it would come out. But to my surprise, it tasted pretty darn good.